Hello, this is Mrs. Huntley. This is Module 4, Solving Systems of Equations. This is Lesson 6, Solving Systems of Equations by Inspection. If you would please open your packet to the page that looks like this in the top left-hand corner. We've got Systems of Equations, student handout number 6. I think we're on page 28 or about page 28. And please add the essential question at the top. How can I tell just by looking at the equations how many solutions there might be? So we've talked about this some in class, but I wanted to make sure that you got some notes and some actual direct instruction on this. So sometimes, we've got some fill-in notes here, sometimes we can determine the number of solutions that a system of equations has by observing and drawing conclusions from the equations. This is called inspection. So I'm inspecting the equations and I'm drawing conclusions based on what I'm seeing. For example, we know that two equations have the same slope and different y-intercept, then the system is going to have no solution. I don't have to graph the lines to know that they're going to be parallel lines and they're never ever going to cross. I just look at the slope, look at the y-intercept. On the other hand, if two equations have the same slope and the same y-intercept, then the system is going to have infinitely many solutions. It doesn't mean that just any number is going to make both equations true, but whatever makes one equation true will make the other equation true. So let's take a look at some examples. I've got two equations here. I'm looking first at my at my slope. So that's the first thing that I'm going to look at. My slopes are the same. My y-intercept, this one I've got a positive 9. This one I have a negative 9. Positive 9 and negative 9 are not the same number. Therefore, I know that this system of equations has no solution. How many solutions does the system have? None. Okay. Why? How do I know this? The equations have the same slope, but a different y-intercept. If I did graph this, I would have parallel lines. Okay. Since parallel lines never ever cross, and we know when we graph our system, the point where they cross is the solution, we know that there's going to be no solution here. Okay, looking at the next one. We have two equations that are not in slope-intercept form. Okay, this is called standard form when you have a number in front of the x, a number in front of the y, and a number here. It's like ax plus by equals c. I know we've talked about it, but we've not spent a lot of time looking at something that is in standard form. What I want to draw your attention to is the matching coefficients. Like we've got a 7 here that's in front of the x. We've got a 3 here that's in front of the y. So our a's are the same number, our b's are the same number, but our c's are not. So that's like saying 7 plus 3 equals 10 and 7 plus 3 equals something other than 10. It can't be, okay? So we know just by looking at these equations without even putting them into slope-intercept form that there's going to be no solution, or there's not going to be any solutions that will make both equations true at the same time. Now, another thing, and I just want to mention this, and again, we're not going to spend a ton of time on systems of equations that are in standard form. You're going to get this more when you're in algebra in high school. But if these had been multiples, the same multiple, like if I had this one said 7x plus 3y equals 10, and this one said 14x plus 6y equals 20, if they were all like the same multiple, greater, then it would be infinitely many solutions. But if the A terms and the B terms were the same multiple, but the C terms were not, then it would be a no solution. So what am I going to use for an explanation here? On this particular one, I'm just going to say it is impossible for 7 times a number plus 3 times a number to have a different outcome. And that's just kind of logic, okay? So I can't add the same 2 numbers together and have different outputs, because the front of this equation is exactly the same. Okay. Looking at the next one, how many solutions does the system have? Again, I'm going to go back. They're both in slope-intercept form. So the first thing I'm going to do is check my slopes. This one is a positive. This one is a negative. My slopes are different. It does not matter what my y-intercepts are. If my slopes are different, the lines are going to cross and there's going to be one solution. Okay? If the slopes are not the same, there will be a solution. The lines are going to cross. Okay. Let's look at the next one. Okay, here I've got one equation in slope-intercept form and the other equation, well, it looks like standard form. It's not quite, because my this value here is negative, which is fine. It's just not truly a standard form. Now, in order for me to be able to compare the equations, notice that these two, I didn't have to do anything. On number 2, I didn't have to do anything to them because they were both in standard form. These two, I could compare them right away because they were both in slope-intercept form, just like number 1. This one, I've got one in slope-intercept form and one in standard form. I can't compare them. Right now, it's like looking at apples and oranges. I need to have them both in the same format. And since we're pretty accustomed to dealing with slope-intercept form, I'm just going to go ahead and transform this second equation into slope-intercept form. So the first thing I have to do is add, oops, I need a pen. I have to add 8x to both sides. And I'll be left with 4y equals 8x plus 2. Now I cannot add the 8x and the 2 together because they are not like terms. So now I'm going to divide both sides by 4. And when I do that, my y is all by itself equals 8 divided by 4 is going to be 2. So I've got 2x. 2 divided by 4 is going to be 0.5, or that's the same as 1/2, right? So this is my new equation. Y equals 2x plus 1/2. Now I can compare my slopes. So let me grab my highlighter. Let's see, I've got a slope of 2x here. I've got a slope of 2x here. I have a y-intercept of 1/2 here and a y-intercept of 1/2 here. So how many solutions is this going to have? Infinitely many. Whatever solution makes one equation true will make the other equation true. So here's what I'm going to write here. First I need to rewrite the second equation so that they are in the same format. Once they are both in slope-intercept form, I can compare my slopes and my y-intercepts. Since they are both the same, When I graph these lines, one's going to be on top of the other. It will look like one line, essentially, but I tend to color code things so you can see that there's two different lines there. Alrighty, so that is the lesson pretty much in a nutshell. Let's take a look at the next page and maybe we can work through some problems together. Match each equation on the left with the equation on the right that would make the system, that would have infinitely many with the system. So let's take a look at what we've got here. Y equals -3/2. So I need to find another one that says -3/2. That's going to be my first order. So that's 2. Nope. There's +3/2. Oh, that we're not in slope-intercept form there, are we? Okay. +3/2. Let's get these in slope-intercept form. Let's do that first. So let me grab a pen. Anything that's not currently in slope-intercept form, let's see, B, I've got to subtract 3x from both sides. So I have y equals -3x plus 6. For C, I'm going to subtract 3/2 x from both sides. So I'm going to have y equals -3/2 x plus 2. That one's already in slope-intercept form. Okay, those were the only two that I had to do. Let's go ahead and see. Now I can say this one has -3/2. Check my y-intercept. So C would be my answer to the first one. Okay, number 6 is not in slope-intercept form, and since I just converted all the ones on the right into slope-intercept form, I need to do the same thing on the left. So this is a little tiny bit complex to do. I need to subtract 2x from both sides of the equal sign. So I'm going to have I'm going to have 3y equals -2x plus 6, and then I need to divide both sides by 3. So I will have y equals -2/3 x. 6 divided by 3 is going to be +2. I'm going to go ahead and convert number 8 right away. I need to add 6x to both sides. Then I'll have 3y equals 6x plus 6. Divide both sides by 3. And I'll have y equals 6 divided by 3 is 2 plus 2. And then the last one is in slope-intercept form. So what I would like you to do right now is pause the video and see if you can match up number 6 to the one on the right that would have, that would create a system with infinitely many solutions. So go ahead and pause the video. Remember, my y-intercept is here. And I need to find one that has the same y-intercept and the same slope. So for this next one, it's going to be A. I want you to go ahead and pause the video again, see if you can figure out number 7. My y-intercept is 3/2. So I've got to find one over here that's +3/2. Oh, I meant to, there we go. So that's going to be D. Next one, check out your slope. I need something that has a slope of 2. Let's see, here's a slope of 2, plus 2, plus 2. So this one's going to be E. And 9. I hope you're pausing and like checking, making sure that you know how to do this, not just copying from me. This one's going to be B. Again, the key here is getting them all into the same format, getting them all into slope-intercept form. If me doing it long ways this way was confusing to you, or there's so much writing on this page, now if that was confusing to you, I hope that you know you can always get a piece of scratch paper and convert them on a piece of scratch paper, not just on this page. Okay, next it says for each equation below, write your own second equation that would make a system with no solution. Then trade papers with a partner and check each other's work. So being that I've only gone 15 minutes here, what I'd like you to do is create your own second equation that's going to have no solution so that when you come to class tomorrow, you can check your work with someone. Now 10 and 11 should be pretty straightforward on how to do it. 12, you're going to have to convert this into slope-intercept form before you can write your second equation. Okay? So I'm going to invite you to have an awesome evening. Summarizing today's lesson, we're going to do 10 through 14 when we get to class tomorrow, because I think it would just be better to do in class when we do have partners. I would like you to try to write those equations. But summarizing this lesson, when you're solving a system of equations, there's three possibilities. There's one solution, that's if your slopes are different. Infinitely many solutions if your slopes are the same and your y-intercepts are the same, or no solution, and that would be if your slopes are the same but your y-intercept is not. Hope you have a great rest of your evening, and I will see you in school tomorrow. Bye.